Now, if there is a full blood count report, right, with high WBC count, right, and when you go to the differential count, when there is a lymphocytosis means lymphocyte amount is more than the other cells, right, and hemoglobin is normal and platelet is low, right? Then directly we can focus on the viral infection, right? When the lymphocytes percentage is more than 40%, when when the lymphocyte percentage is more than 60%, and the total WBC count is more than 20,000, 30,000, right? If the platelet is less than 150, and the hemoglobin level normal, right? If that and other all RBC indices or red blood cell indices are normal, right? Then you can directly focus on to the acute viral infection. In that case, right, you can expect some viral or reactive lymphocytes. Don't use the viral lymphocyte word, right? Reactive lymphocytes in the blood smear, right? Then they can give that type of full blood count report, and they can ask, what is this pathology, what is this clinical condition? That may be a viral infection. Then they can ask, right, what are the special type of cells you can see in the blood smear? Then you can say reactive lymphocytes may be seen, right? In that type of questions they can ask, right? Okay. Now we will move to another different kind of blood abnormality, blood cell abnormality. This is a neutrophil actually. This is a neutrophil, and you can see in cytoplasm lot of granules. This is a bad form metamyelocytic neutrophil, bad form neutrophil. Actually, uh, normal neutrophil, normal neutrophil is affected due to one thing. What is this thing? This is a bacterial infection. Because of the bacterial infection, you can see this type of granules, right? When they are now think when there is a full blood count report with high neutrophil count and high white blood cell count and normal platelet and normal hemoglobin, right? That normally we know that focuses to the bacterial infection. Then in that blood picture, you can see a lot of neutrophil with these type of granulation in the cytoplasm. This granulation we call as toxic granulation. This is not a myelocyte. Okay, remember this is not a myelocyte. This is a mature neutrophil with toxic granulation. Right? You can see these type of you can't see these type of coarse granulation in the myelocyte. Right? You can see this coarse granulation due to the toxicity of the bacteria. That means these are toxic granules, toxic granulation. They can ask, they can give a blood picture of high neutrophil count and with this type of granulation, and they can ask what is the inclusion granules you can see in the neutrophil, right? These are toxic granulation. Okay. Next one. I'm sorry about the delay because my computer or laptop is somewhat slow, right? People are admitting that's also give a rush to this. Still people are connecting to this. Okay, now okay. They can give a blood picture like this. Now here, can you say any abnormalities? Yes, you can see here. These are not immature cells. Actually, these also neutrophils. Now here, neutrophil lobes are broken, and here you can see neutrophil lobes, neutrophil nucleus start to lyse, right? Start to lyse. Actually, this is because of what? When you observe these type of cells, directly you tell this is because of EDTA changes, right? Because of the prolonged storage of blood in the EDTA, you can see these type of neutrophils, right? Except of this, what are the other changes you can see in the blood smear with the delay when you process a delayed sample? Actually, that is not preferable, but you don't know the time of transportation. You started the blood full blood count, and when you observe this blood picture under the microscope, you can see this type of cell. Then this is because of EDTA changes. Another EDTA change is neutrophil vacuolations. You can see in the cytoplasm, you can see some vacuoles in the neutrophil. But usually in normal, so when you consider about the normal white blood cell, 5 types are there. Out of that, you can see the vacuoles of the cytoplasm in only the monocytes. But in EDTA change or EDTA, because of the EDTA effects, right? This neutrophil cytoplasm also may have some vacuolations, right? Then RBC fragmentation or RBC crenation. RBC crenation means the margin of the, you can see margin of the RBC crenated, red blood cell crenated, and EDTA induced platelet clumping also you can see. You can see platelet clumps even though you collect this sample in a very correct manner, even though the sufficient amount collected, you can see, even though you mix it well, you can see with platelet clumps on the blood smear. That is because of EDTA induction. EDTA in some, that is a type of autoimmune disease actually. In some people, right? When you put this blood into the EDTA container, automatically platelet will start the aggregation, right? That is called EDTA induced platelet clumping, right? What is the solution you can take? Then they can ask this in the Viva, right? What is the solution you can do for that? What is the solution? You can collect the patient blood into the citrated blood actually. Trisodium citrate, 3.2 trisodium citrate you can use. You can collect the blood as collect into the coagulation studies, right? You can collect the blood into the PTI in our tube, citrated tube, and as soon as possible, okay? Not without delaying the sample, as soon as possible, within half an hour, you have to process the blood sample, and you can do the full blood count by using that. And you can observe the morphology also. You can observe the morphology. You can draw a blood smear and stain with the Leishman or IMSA stain, Romanowski stain. Then when you observe under the microscope, now you can see platelets are distributing and nicely evenly distributing, and you can have idea about the platelet count, right? But you can do the manual count by using that secreted blood also, because that type of special case or patient with suffering with that EDTA induced thrombocytopenia or EDTA induced clumping, you have to collect the sample definitely into the secreted container, right? If that is, if you fail to do that, definitely patients platelet always gives false low results. Not only that, partial clumps also can present in the blood, and that gives low results to the white blood cell count, right? Therefore, you say, you give the answer as you have to collect the sample into the citrate container, right? Trisodium citrate container. Then, to give the revisions about the anticoagulant used in the hematology lab, right? I will tell some examples for the anticoagulant. EDTA means ethylene diamine tetra acetic acid, right? Then EDTA percentage is you have to use 1.5 milligram to collect 1 ml of blood. 1.5 milligram to collect 1 ml of blood. Actually, nowadays we are not using EDTA bottles. Nowadays we are not using EDTA bottles. Then they can ask what is the percentage of commercially available EDTA containers. What is the percentage? That is 10% EDTA or 7% EDTA, right? Both percentages present. Mainly 10% EDTA present in our commercially available EDTA containers, right? 10%, right? But normal routine practice, and when you give the answer for the EDTA concentration, you have to tell 1.5 milligram per 1 ml of blood, right? Then when I talk about the sodium, trisodium citrate, usually you EDTA anticoagulant used for full blood count, then reticulocyte count, right? Then reticulocyte count, NAPSCO. When you do NAPSCO, you use the EDTA blood in hematology, right? And when you do the PCV, back cell volume, you use the EDTA anticoagulant for the blood collection, right? And blood picture. when you do the blood picture, you have to collect sample into EDTA. And especially you have to mention, right? If you, they can ask, if you need to do some blood picture, right? Or there was a complaint from PBU or pediatric clinic, your hemoglobin level always getting low, or your platelet level getting low. That type of complaint can come. That time, what is the main pre-analytical error that you can resolve? You have to give them, right, pediatric EDTA tubes, right? They should advise, they should advise not to collect the pediatric samples into the adult blood EDTA containers, right? Because they collect only about 5 microliter blood, 5 microliter blood. Then you can collect 5 microliter into the pediatric EDTA container, right? That's a one pre-analytical error you can give as answer for that complaint, right? Then another thing, trisodium citrate. Next, anticoagulant trisodium citrate. 3.2 is the percent. 3.2% trisodium citrate we can use in coagulation studies. Prothrombin type, APTT, and thrombin type. Not only that, another coagulation study routinely we do, that is called mixed study or factor correction. Usually we can do that in routine laboratories. They can ask the questions related with the factor correction or the mixed study, right? I will explain it later, right? Just remember now, right? For that one also, you have to collect this blood into the trisodium citrate container, right? 3.2 trisodium citrate. Ratio is 1:9, 1:9, right? Why I am repeating these? To give the revision for the all the participants. Sometimes some participants may be there in the first time to give the repetition, right? This repetition is also very important to any period, right? Okay, 1:9 is the ratio. What is 1? 1 is 3.2 trisodium citrate, 3.2% trisodium citrate, 9 is blood. You have to collect 9 part of blood into the container. What are the volumes actually? 0.2 citrate, 0.2 ml citrate, then 1.8 milliliter blood, right? Then actually sometimes they will not ask the volume ratio, but you have volume, but you must know the ratio 1:9, right? Then how you advise to the ward staff to collect the blood to the PTI, right? That's a very common question these days they are asking, right? How you advise, right? Definitely, you should take the ward staff should advise to take the correct anticoagulated container. That may be blue cap, right? Mostly that is blue cap bottle, blue cap tube, right? Containing trisodium citrate. They must select that, right? Then they should not apply turning to sample collection. They should use white bow size, white bow size needle, that is 22 to 23 gauge needle is more preferable, right? And they should not apply the sample into the container through the needle, right? That's a very important thing you have to give advice, right, to the ward staff not to transfer the blood into the container through the needle. You have to remove the needle and you should add the sample into the container, and you must add the sample up to the level of the citrate tube, and by gentle inversion 8 times or 10 times you have to gently invert without shaking. That is the proper mixing way, right? You should not shake the blood, but you have to gently mix by inverting the tube 8 to 10 times, right? That is the way of mixing. Or you can roll it between your palms to mix up the blood there, right? Then correct labeling, and as soon as possible, within 2 hours, you have to perform the PT test. And another thing is, when you transport this blood to the PTINR test, you have to transport that in room temperature, right? When you transport the whole blood, right? If you can separate the plasma from the secreted blood, once after you separate the plasma from the blood, you can keep it in ice until it transport to the laboratory, right? Without that, don't tell, right? Today also that question arises, right? They asked in Viva, right? What is the transportation condition? Some people told on in ice, right? That is wrong. They told that wrong. That is because of they asked about the whole blood. You have to transport the whole blood or the whole blood container for the coagulation study, especially PT test, you have to transport in room temperature and as soon as possible. Within 2 hours, you have to do the test, right? Okay. Then those are some details related with the PT and how to collect the samples and some important points, right? Okay. Then I am talking about the EDTA changes in the blood smears actually. Then I told, now I am talking about the anticoagulants. I told about the EDTA. Then I told about discussed about the trisodium citrate. Out of 3.2%, we can use 3.8% trisodium citrate in ESR test, right? Then ESR test we can use 3.8. Actually, you can use 3.2 also, right? 3.2 trisodium citrate also you can use. That is the most new update of the anticoagulant for the ESR, right? Then the ratio is 1:4. 1 part of anticoagulant, 4 parts of blood, right? Okay, that's trisodium citrate. Next anticoagulant we use in hematology is heparin. Heparin we used in osmotic fragility test. Osmotic fragility test we should use heparin. Another test is PCV. Actually, that time we not at anticoagulant to the tube. That heparin or heparinized capillary tubes will come commercially. We must use that capillary or tubes, heparinized capillary tube for do the PCV test. You understand? Then heparin use in the hematological investigation, especially osmotic fragility test and PC, right? Then what is the unit? Unit is 20 to 30. Most preferably 25 international unit is that is prefer for more suitable for the hematological investigations, right? Okay, that is heparin, right? Those are the major anticoagulants used in the hematology lab, right? We'll move to the next slide. Basically, one clear neda.
Oh, sir.
Right. Okay, now you can see these are the platelet clumps, right? That is because of sometime delay due to the collection error, right? Delayed collection, okay, or due to the EDTA induced clumping, right? This if you seen this type of blood smear, right? Actually, this question they asked in the previous OSPI, right? They gave a chart, right? They gave a chart, right? Previous they gave a chart. I will picture, right? Now here platelet clumps, right? Platelet clumps percentage 1 minute. I hope you can see this board, right? In a full blood count report, we can see these type of charts, right? These type of charts, right? And we can see these type of scatter plots. That's the type of chart, right? This type of scatter plots you can see in your full blood count report. The previous OSPI actually they gave this type of chart. These type of charts, right? Three charts you can see, especially in your full blood count report, right? These type of charts we call as histograms. Histograms, right? These type of scatter plots or charts we call as scattergram. This scattergram is related with WBC, white blood cell, or white blood cell differential count, and NRBC count, and retic count, right? These scattergrams related with the white blood cell differential count, NRBC count, and the retic count. Histograms are related with the red blood cell count, RBC count, and platelet count. What I need to say here is, right, now you already seen platelet clumps are there. If you have platelet clumps in your blood, right, your platelet histogram gives a different elevation, right? Usually, when your platelet histogram is like this is the mean platelet volume, this is the mean platelet volume, right? Then graph is goes like this and again elevating from here, right? This graph was given in previous hospital, right? This is because of this area is uh, because of the giant platelets or platelet clumps, because of the giant platelets or platelet clumps. Right? This you can see in the platelet histogram. Here, the platelet volume is elevated or high value. When you go to the x-axis, when you go to the right-hand side, that right-hand side, you can see some more platelet volume. This says there are some platelets with high volume. Actually, this is because of this may be due to the giant platelets or platelet clumps. Remember, right? If a graph given like that, you tell there may be platelet clumps. If you observe this type of platelet histogram, you go to the blood picture and observe whether there are platelet clumps present or not, right? Right. When you observe this type of platelet clumps, you can see that histogram changed there, right? Okay, we move to the next. Right. Now you can see again, these are some different type of cells. Now I hope you can see my cursor point here, right? When you go to this cell, you can see, right, the cytoplasm color is equals the cytoplasm color of red blood cell here, equal. But there is a nucleus, pyknotic nucleus, that means condensed nucleus, dark blue stained round nucleus present in the periphery of the cell, right? This is a pyknotic nucleus or dark blue nucleus. What is this cell? The nucleus present in red blood cells, that is nucleated red blood cells, NRBC, right? This is a mature NRBC, and you can see there is another NRBC, but here this NRBC size is high, right, than the normal red blood cells. But this also a NR nucleated red blood cell or NRBC. This is intermediate NRBC. You don't need to write intermediate NRBC. This is however NRBC. You have to identify this as a NRBC. This is also a type of NRBC. Right. Now, what I need to say related with this NRBCs. Okay. When you observe NRBC in your blood film, right, they can ask what are the changes that you can see in the full blood count report. What I need to say is white bloods, when you do the full blood count in the analyzer, right? If the full blood white blood cell count is more than 20,000, 30,000, right, or high count, right? But actual count of the patient is not that much of high, right? When you go to the manual white blood cell count, okay, actually you can't identify these NRBCs, right? Uh, I need to say what is the manual white blood cell fluid, that is 2% acetic acid. 2% acetic acid is the manual white blood cell diluting fluid, right? When you do the manual white blood cell count, you must use 2% acetic acid solution, right? The ratio is 1 is to 20, right? 1 is to 20 is the ratio. You should add one part of solution with, sorry, 0.38 solution to 20 microliter blood. No need the volume. 1 is to 20 is the ratio, right? 2% acetic acid is the solution, right? Okay. When your white blood cell count is high in analyzer report, and when you observe NRBCs in the blood smear, definitely you should not give the report without do the correction. You must do the white blood cell correction, no WBC correction, NRBC correction, right? How you do the NRBC correction? Again, very easy. Now guess your total white blood cell count is 20,000, right? And you have to do the, you should count the number of NRBC to do the count. You should count 100 nucleated cells or 100 white blood cells, including NRBC. Then you will receive a percentage. Just think that is 50%. 50% NRBC. Your value is NRBC 50%. Then how you do the correction, right? How you do the correction? You find out the absolute NRBC count. How you find out the absolute NRBC count, right? How you do the absolute NRBC count? Now, your total white blood cell count is 20,000. Then NRBC count is 50%. Then how you do the absolute NRBC count? Absolute NRBC count is equals, right? 20,000 into, right? This is then 10,000. 10,000. Your absolute NRBC count is 10,000. Then in report, how you should give the report? Total nucleated cells. Total nucleated cells are 20,000. 20,000 per cubic millimeter, and NRBC count is 50%. 50%. Then this is how you should give the result or report, right? Then what is your absolute count of NRBC? That is 10,000. Then your corrected count should be 20,000 minus 10,000. Then corrected WBC count. Corrected WBC count 10,000. 10,000 per cubic meter. This is how you should give the report, right? These are the questions they can ask in the Viva, right? Right. Then these are the NRBC. And another thing, when you observe a blood smear from a patient suffering with CML, chronic myelogenous leukemia, or chronic myeloblastic leukemia, you can see NRBC in the blood smear, more NRBC in the blood smear. And in healthy people, actually NRBCs should not present in the blood smear, but especially in neonatal blood pictures, samples from the PBU, samples from the pediatric clinic. In small children, we can see some NRBC, especially neonate. In neonate blood, you can see the NRBC, right? Then you must do a NRBC correction before you do the full blood count report, from especially to those people, right? Neonates, right? Then I need to say NRBC about the NRBC. Another thing is, when you observe more NRBC in the peripheral blood smear, right? That may be another reason for that NRBC, due to the high production of red blood cells because of RBC hemolysis, right? If the patient suffering with any hemolytic anemia or hemolytic condition, you can see NRBC on the peripheral blood smear. Then they may ask what are the conditions that you can see these type of cells in the peripheral blood smear. Then you can give the answer in hemolytic conditions or in hemolytic anemia, right? In blood malignancies like CML, and in neonatal blood, you can see NRBC. Another malignancy, AML-M6 or erythroid leukemia, you can see this leukoerythroid blood picture. Leukoerythroid blood picture means blood picture with nucleated red blood cells. Okay, right. I think that's enough about the NRBC. Okay, again, very important test, right? This may come because this test still at the moment up to this level they ask this test, but they ask about they already asked about the osmotic fragility test. They asked, and this is Brewer's test. Okay, Brewer's test normally we used to used in identification of G6PD, G6PD deficiency or G6P deficiency, G6P deficiency, G6PD deficiency. The test screening test we use, that is Brewer's test. When you observe a picture with these type of brown color two tubes and this type of red color tube, this is no doubt, right? Positive control and test, you can see this is brown color, and negative control, that is pink color. This test is Brewer's test. What is the disease we use this test? Disease is G6PD deficiency, right? In G6PD deficiency, what are the special cells you can see in your blood picture? Blister and white cells. Blister and white cells. Sometimes they can give blister white cells, in the blister and white cells in the blood smear, and they may ask what is the disease condition, what is the clinical condition of the patient. Then you have to say that is G6PD deficiency, and they may ask what is the screening test you can do in your laboratory, that is Brewer's test. Okay, I will tell about this test. You take patient blood and normal blood for do this test, right? Then you add, right, sodium dextrose sodium nitrite mixture into the blood. Then sodium nitrite what do? Convert your hemoglobin into methemoglobin. Actually, you added this dextrose and dextrose sodium nitrite into all three testings, right? Then, sorry, positive control and test only. Positive control and test, right? The negative control, you don't have sodium nitrite. Then actually sodium nitrite what to convert hemoglobin into the methemoglobin. Then you can see that brown color. You can see the brown color. Then what you add? Second solution is methylene blue. When you add methylene blue into the solution, if the patient is having normal G6PD level, if the patient is having normal G6P level, right, that brown color again convert into the pink color. Brown color again convert into the pink color. That is because of that methemoglobin reduced into hemoglobin again by methylene blue. Okay. Therefore, you use the name for this Brewer's test called as methemoglobin reduction test or methylene blue reduction test, right? Methemoglobin reduction test or methylene blue reduction test. In normal G6P level, right, that methemoglobin again converted back into the normal hemoglobin. If the patient is not suffering with this disease, definitely once you add methylene blue to the blood at the second step, that brown color convert into the pink color that you can see in the negative control. If the test shows the same color, that test is negative. Now can you tell this test what is the result of this test? This is positive because that equals to the positive control curve, right? This is the Brewer's test. Then I told you can see, right, some different RBC because of this G6P deficiency, that is blister and white cells, right? How these blister and white cells produce in the blood smear, I told the previous day also, right? Then this is happened due to the oxidative damage of the red blood cell membrane, right? What are the blister cells? Blister cells you can see in the blood smear. Normally, this is the blood cell. Then one area that without hemoglobin, like this. Now this is the hemoglobin area, and this is the central talover, and this area don't have hemoglobin. This is like a blister. These type of cells called as blister cells, right? Blister cells. And what are the white cells? White cells are like eating cells, right? Like a biscuit, right? This is the red cell filled with the hemoglobin, and one side broken, right? Like this. These are white cells. When you observe more major population of these blister cells and white cells in the blood picture, and when you have a hint of anemia, that means hemoglobin low, right? Hemoglobin low, then you have blister and white cells in the blood picture, right? RBC, you can see a lot of red cell fragments in the blood picture, then you can guess, you can suspect this patient suffering with G6P deficiency. Then you have to do the screening test, Brewer's test. By doing the screening test, you can find out whether there is a G6P deficiency. Then, as a confirmatory test, you can do G6P enzyme assay. G6P enzyme assay you can do as a confirmatory test. And another thing is G6P enzyme assay you can do. Another thing is before you do this test, you must do a reticulocyte count of this patient. Why? There is a one thing you must know, that reticulocyte affect to the G6P enzyme level. That reticulocyte falls will elevate the G6P level. Then if the patient having high reticulocyte count, you can't do the test at that level. You understood? Therefore, actually, that is not doing usually, but that must do, right? Reticulocyte count do before you do the Brewer's test. Understood? And this is about the Brewer's test. I hope you understood you got some point from that area, right? Okay, this picture can come to the OSPI next, right? 12 or 16, this picture can come, I guess, right? Don't blame it, if not came. I think this will come, right? Okay. Okay, I previously told about the a mixing study. What is mixing study, right? That's a type of coagulation study, right? Now, don't think about this slide and listen to me. If you have a patient with high APP, normal range of APP level is right 20 to 40, no, 20 to 40 seconds. 20 to 40 seconds is the normal level. If you have a patient with high APP, right, your clinician maybe, your hematologist maybe request you to do a mix study. Okay, what is the mix study? There may be OSPI, right? In APTT high patients, right?